We have all been there. You spend weeks building the perfect IoT project. You solder it, permanently seal it inside a 3D printed case, mount it outside, and instantly realize there's a bug in the code. Do you tear it all apart just to plug in a USB cable? Absolutely not. Today, I'm showing you exactly how to flash ESP32 over Wi-Fi. We're going from a basic desktop setup to building a captive web portal for end users, and finally, building a completely autonomous, self-patching device that pulls updates directly from GitHub. I've put a link to all the copy-pastable source code down in the description so you can easily follow along. Let's cut the cord. But real quick, before we dive into the code, I just want to say a huge thank you to everyone watching. We're all makers here, just trying to build cool things. If this video saves you some headache, hitting that subscribe and like button is the absolute best way to support the channel. I read every single comment, and your feedback directly dictates what I build and teach in the next video. So tell me what you want to see. Alright, let's get into it. Before we can upload code to ESP32 wirelessly without USB, we have to understand the ESP32 OTA partition scheme. Microcontrollers don't just overwrite their own brain while they are thinking. That would instantly brick them. Instead, the ESP32 divides its flash memory into two partitions, app0 and app1. It downloads the new update into app1 in the background, verifies it, and only then flips a microscopic switch to boot from the new code. To do this, you need enough space. In the Arduino IDE, go to Tools, Partition Scheme, and select Minimal SPIFs. If you're on Platform I/O, you'll need to set your board partitions to an OTA CSV file. Part 1 is an ESP32 over-the-air update basic tutorial. This is a push update perfect for your workbench. Notice how my device magically shows up in the Arduino IDE port list without me knowing its IP address. That is called MDNS. If you've been wondering how to set up Arduino OTA on ESP32, you just include the library, set a hostname, and run begin in your setup. But here is a trap. Your loop is sacred. You must place the Arduino OTA handle function inside it to constantly listen for incoming updates. If you use a blocking delay anywhere in your code, you will completely miss the OTA handshake. You must always use millis for timing. And hey, if transitioning away from delay is daunting, don't panic. I made a dedicated video breaking down exactly how to use millis to achieve true multitasking on your Arduino. Scan this QR code or hit the link in the description to check that out. Also, add a password. If you don't, anyone on your Wi-Fi can hijack your board. For testing, I uploaded code that blinks an LED every 2000 milliseconds. I change it to 500 in the IDE, hit upload over Wi-Fi, and boom, it updates wirelessly. That is how to flash ESP32 over Wi-Fi Arduino IDE style. But wait, Arduino OTA is great for your desk, but what if you sell this device to a customer? They don't have the Arduino IDE installed. We need to host a firmware update web page on ESP32 itself. Web browsers can't compile C++ code. For parts 2 and 3, you need to know how to extract the raw compiled binary file, the bin file, from your code editor. If you're using the Arduino IDE, simply go up to Sketch and click Export Compiled Binary. The IDE will generate a bin file right inside a build folder next to your sketch. If you're using Platform I/O, it's even easier. After you build your project, just look in your file explorer under .po/build/your board name, and you will find a file named firmware.bin. Microcontrollers have tiny amounts of RAM. If a user uploads a 1 megabyte bin file, the ESP32 will instantly crash. The secret here is streaming versus buffering. We are going to write the file chunk by chunk directly into the flash memory. To do this, we are going to use an ESP32 Wi-Fi Manager custom HTML OTA update. I'm not covering basic Wi-Fi Manager setup today, but I have a full ultimate guide video on it. Scan this QR code or check the link in the description to watch that first. We don't want to hard code our Wi-Fi credentials, so we use Wi-Fi Manager to spawn a captive portal. But we are going to hijack its internal web server. We write a custom HTML form. The secret source is encoding type equal to to multi-part form data. This tells the browser to send a raw binary file, an ESP32 web server firmware upload bin file, instead of standard text. We clean up the default menu and inject a firmware update button. Then we create custom web routes. When the user hits upload, the ESP32 uses the core update class. It begins the stream, writes the chunks to flash, and ends it by cryptographically verifying the file. Look at this. You press a physical factory reset button, connect to the setup network, and you can now do an ESP32 update firmware via web browser portal straight from your phone. That is exactly how to build an ESP32 captive portal for OTA updates. Okay, web portals are amazing for smart home hubs in your living room. But what if your project is a solar-powered soil sensor in the middle of a forest? You can't walk up to it with your phone. We need to completely switch our thinking from push updates to pull updates. Your device needs to actively query the cloud. We're going to build an ESP32 auto update firmware from GitHub releases. Connecting to github.com is incredibly heavy for a microcontroller. It requires an X59 certificate chain of trust to prove it isn't talking to a hacker. And SSL certificates have strict valid from and valid to dates. So before we can do anything, we must ping an NTP server network time protocol, so the ESP32 knows the actual real-world time. Once the time is set, the ESP32 wakes up and checks its hard-coded firmware version against the GitHub API. This is how to skip updates if ESP32 firmware version is the same, saving massive amounts of battery and stopping infinite download loops. The GitHub API sends back a massive JSON payload. If you try to hold all that in RAM, your ESP32 will crash. Here is how to parse GitHub release JSON ESP32 Arduino style. We use Arduino JSON filters. These act like a sieve, instantly throwing away the junk and extracting only the version number and the download URL. If the versions mismatch, it's time to download. But here is one trap that can drive developers crazy. GitHub doesn't actually host your compiled bin files. When you ask for the file, they hit you with an HTTP 302 redirect to an Amazon S3 or Google Cloud server. If you've been banging your head against the wall wondering how to fix GitHub redirect errors, this is why. The basic HTTPC line gets confused because the security certificate completely changes mid-download. We have to write a custom function to intercept the headers. This is how to make your ESP32 HTTPC client follow redirects. When we detect the URL changing to Google storage, we dynamically swap the security certificate from the GitHub intermediate cert to the Google GTS root cert. This ensures your ESP32 HTTPU update GitHub root certificate validation succeeds. That is exactly how to handle Google Trust Services cert ESP32 GitHub redirects. Once the certificate is swapped, the ESP32 successfully executes an ESP32 secure OTA update HTTPS GitHub API pull. It streams the file, safely verifies it, and reboots. Then, it goes straight back into an ESP32 Deep Sleep Auto Firmware Update check cycle. You can now publish a release on your laptop, go to sleep, and wake up knowing every single one of your devices around the world autonomously downloaded the binary file from GitHub releases. We covered a ton of intense code today. Don't worry, I have a fully detailed companion tutorial on my website with all the copy-pastable source code. The link is in the video description. You just leveled up from plugging in USB cables to deploying professional, self-patching IoT hardware. What kind of remote devices are you planning to auto-update using this? Let me know in the comments. Hit subscribe so you don't miss the next project, and I'll see you in the next one.